Students, welcome to all of you. Yes, good evening. Good evening. Can you explain once about stacks? What? Oh, wait, there is one message. Let me check. Yeah, students, welcome to all of you. Welcome to Wings of Hero. Just now I received one message from Yuvashri. Good evening, sir. Good evening, Yuvashri. Can you explain once about stacks? What the use of stacks and where should we use such type of components? Okay, sure. Yeah. Yes. So here we have one component. This is our stack component. We have to add this stack component. We can use this component. By using this component, we can create our aircraft components such as CD nozzle, even fuselage, okay, and your wind tunnel. Okay, like that, different components we can create just by varying the parameters what we have here. Okay, and also nozzle kind of shapes also you can create, and also your aircraft nose part or aircraft body. I'm like especially aerospace vehicle, especially missiles or rockets. That kind of body also can be done with the help of this component, stack geometry component. Just you have to change the design policy, okay, and you have to vary its parameters and also the cross sections. Okay, and here you can come to cross section. You can change the cross section type like this, and also this stack type of component we can use even to complete our engine section. I mean, like engine parts also can be done with the help of the same component, that is stack geometry. Is that clear, Yuvashri? So this is our CD kind of nozzle. Here you can come to mid section and you can vary its parameter again like this, and also you can increase its length. Yes, okay. Yeah, thank you. Okay, then we'll continue. So students, as we know, we are dealing with this aircraft Cessna 210, and also we have completed our first part. Okay, I will take out the part, open. Here we have our first part, that is fuselage part. Here we have top view, front view, and left view. Okay, and already we have saved this part yesterday itself. Now we'll be going to discuss about the next part of our Cessna 210 model, what we have here. Second part, that is the main wing. Okay. So with respect to this main wing, we have all the parameter here. We'll take these parameters. I'm like dimensions. Okay. I'll take one more whiteboard. Yeah. Now it is easy. So here we will continue with our second part. That is main wing. Okay. So the main wing of our aircraft parameter is mentioned here. Overall span. Okay, which is in meter. Okay, so we are dealing with the feet. I'll mention the values. Just all of you type that. So here main wing part 2, overall span is 160. Okay, so 62 11 meter. Okay, so all of you take overall span 42 feet. Okay, and area generally I'll just write yes 160 feet square. Okay, and overall our aspect ratio 11.02. Okay, and chord length 3.80 feet. Okay, for this wing, overall span B. Okay, this B value is given here 42 feet. Yeah, so what we'll do in the open VSP, we have done with the fuselage, no? So go to file, new. Okay, now go to geometrical browser, select wing and add. Yes, so here we have our default wing. We have to change this default wing as per our requirement. And like we have to design our main wing and we know our parameters, right? So we'll use those parameters and we'll type here. Come to plan, overall span, as I told just now, overall span, also I have written 42, right? Okay, 42 feet, enter, chord length 3.80 feet, enter, and area is 159.60. Of course, you will get 59.6, or else you can round up to 160. Okay, these all things already it's calculated value because we know aspect ratio AR is equals to B square by S. Okay, you know this formula. Yeah, automatically we got our area. No need to type, or else you can round up to 160. 160 feet square. Okay, yes. Now, yeah. So here, whatever value we have given, based on that, we get our aspect ratio. Okay, let it be the default aspect ratio. Now, we will come to section. Okay, so here click this image also. Okay. So now what we'll do, is it not necessary to split this wing? I mean, like, now directly we can use the wing section, only one wing section what we have. Okay, no need to split this wing. Let it be the complete wing section. Default what we have one. Okay. Yeah. So what we'll do now, we'll check all these parameters. Span is given. Root code, okay, let it be. I don't think so. We need a sweep angle. Okay. We'll just change that to 0 because here we can observe we don't have any sweep, right? Sweep angle is 0. This wing is not shaped like this. Okay, it's completely straight, like a rectangular type. Right. So that's why we'll change the sweep angle and we'll give 0 degree. Okay, yeah. Now let's come to aerofoil. So default aerofoil what we have, that is NACA 4 series, which is having the thickness to chord ratio 10% and no camber. Okay, let it be default aerofoil. No need to do any changes. Okay, yeah. So even you can add the default aerofoil. AF file is nothing but aerofoil file. Like this, you can add default aerofoil, root side and tip side. Or else you can read your file. So currently, what else? Just use 4 series default aerofoil, whatever you'll get. Okay. Now we'll save this file. Before that, let's check all the views. We have top view. Span is done. Chord is done. Okay. Yes. Okay. Now we will save this file. This is our part 2.
So screen is not visible.
Screen is not visible. Wait, let me check. Okay. Just 2 minutes. I will share my screen actually. I hope now it is visible.
Yes, sir.
Yes. Thank you for the confirmation. Yes. So here, what we have done, we have added the default aerofoil, wing, and we have changed the parameter. Okay, we have given our parameters. Okay, and based on our parameter, we got our wing. So here, what I have told aerofoil, you can use the default aerofoil, or else you can read your file. Okay, how to read the file? Just go to choose type aerofoil type AF file. You can read your file. Now currently we don't have any such files. I mean like programmatic files. In our open VSP directly you will get such file also. Okay, just go to downloads. There you have set of files, default files that also we can use. Now currently we are not doing any analysis. So just select 4 series aerofoil. Okay, and we'll go with the thickness to chord ratio 2%. Okay, and it is located at a okay, we'll go with the 20% itself. Yeah, same root side. We'll go with 2% camber, and yeah, 2210. Okay, now we will go to file and we'll save this one. So this is our part 2. Accept. Yes, now we'll go for horizontal stabilizer. This is our part 3. So this is our horizontal stabilizer. Okay, now we'll come to open VSP, go to file and new. Again we have to add wing itself. Yes. Okay. Overall span is required now. Right. So for this horizontal stabilizer, overall span is PAN. It is 12.9 feet. Okay. And chord length 2.96 feet. Okay. And the calculated area, yes, is equals to 43. No need that one. Okay. So directly I'll just type aspect ratio AR 3.83. Okay. Yes. So now we'll come to open VSP. We'll come to subsection. Oh, sorry, span. Overall span. We know. Okay. For this wing, that is 12.9. Enter. Okay, and chord length 2.96. Enter. Whatever you will get area, let it be. Okay. And aspect ratio, yes, let it be. No need to do any changes. Okay. So once you calculate manually, you'll get approximate 40, 42, 40, 33, 38, like that. Okay. So here for our input, that is overall span 12.9 and chord 2.9 feet. For this case, area is 38.18 feet square and aspect ratio 4.35. Okay, yes. Now what we will do, we'll come to section. Okay, so here we'll observe once again. Yeah. Solving is like this. No? I'm like horizontal stabilizer. Okay. So this is our symmetry part. Okay. We'll come to section. Here in this section, what we'll do now, we'll split this section. Okay. Because from here to here and from here to here, we have to show this portion. No? Suppose this is your reference line or symmetry line. Okay. What we have to do, we have to show our this portion and this portion, this one and this one. So that's why what we'll do, we'll split our complete wing section into two sections. Okay. From here to here first section and from here to here second section. Okay. Yeah. We'll come to open VSP. We'll just use a split option only one time. Okay. So our complete wing has been split into two parts. From here to here one and from here to here second one. Okay. First wing section and second wing section. So first wing section. Okay. The span of first wing section, which means let me copy this figure. It will be clear for you. Yeah. Okay. So this is our first section and second section. So from here to here span. For first section, the span is 0.78 feet. Okay. Let's type here. First section span 0.78 feet. Okay. And the root chord is 0.5 feet. So for the first section, root chord is this one and tip chord is this one. This one. Okay. And for second section, this one become root chord and this one become tip chord. That is what we have to do here. Okay, so we are in the first section. So for first section overall span, I told that is 0.78 feet. Enter. And root chord of first section 0.5 feet, and tip chord 4.3 feet. Enter. Okay. Yes, everything is done. Now, what we'll do, here we don't want sweep angle, so we'll just type 0. Now we'll jump to second section. Yeah. So second section span, which means from here to here, from here to here, second section span is 5.56. Sorry, 5.66 feet. Okay. And root chord, it will be 4.3 itself. Why? Because for first section, the tip chord of first section will become the root chord of our second section. So which will be equal. That is 4.3 feet. Only we have to change the tip chord. So second section tip chord is 2.61 feet. 2.61 feet. Enter. Okay. And here, of course, we don't want sweep angle. So just type 0. We don't have any sweep angle. Okay. Yes. Okay. Everything is done. Yeah. So why we have gap here? Because we have to place, or we have to assemble our vertical stabilizer. That's why. Okay. Now we'll come to aerofoil. Okay. Let it be the aerofoil, whatever we have default. Okay. No need to do any changes. Now directly we'll go to next component. Okay. So before that, let's save this one. Go to file and save as. So this is our part 3 horizontal stabilizer. I'll just write HS accept. Okay. Now we'll go for vertical stabilizer. This one. Mm, okay. Mm, okay. So here we have our next part. Sorry. Part 4 vertical stabilizer. Okay. Yes. Now, of course, we have to select wing itself. So before that, we'll save this one. Already saved, right? Okay. So we'll go to file and new. Select the wing from geometrical browser and add. Okay. Yeah. Mm, Now for our vertical stabilizer case, symmetry of our wing is not required. So what we'll do, we'll come to X form and we will off this symmetry. What we have on the plane XZ. So we'll off this check box. Yes. Okay. So here the section is varying. else we can say our vertical stabilizer span is varying from root to tip. Okay, from this point to this point, or generally we can say from root to tip of our vertical stabilizer, it is varying. Okay, so that's why we have to split our wing into one, two, three, four or five sections. We'll come to section. Yeah. So before that, we need parameters. No? Overall span from here to here. Overall span B. Okay. I will just type here. Yeah. So vertical stabilizer span 5.111 feet. And chord length 4.7 feet. Okay, we'll use these two parameters. Okay, yes. We'll come to plan overall span. Just now I told 5.11 feet. Enter. Okay, and our chord length root chord. Okay, not tip chord. 4.7 feet. Okay, 4.7 feet. Enter. So automatically you'll get your aspect ratio and area. So let it be the default, whatever you got for those two parameters. Okay, so only we have used two parameters, span and chord length. So based on that two parameter, rest two parameter automatically we got aspect ratio and area. Now we will come to section. Okay, so here, as I told that we have to split our section because the wing is completely only one section. Now currently what we have this wing, no default wing. It is completely only one section where we can't show this kind of shape. I mean like we can't generate this kind of shape when if we have only one section. So that's why we will split this wing into number of sections more than 3, 4 or maximum 5. Okay, by using that number of sections we can come to each and every section and we can vary the span so that we'll get structure of our vertical stabilizer like this. Okay, so we'll split our wing 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so now we have 5 number of sections. Now we'll come to each and every section. Yes, so here we have first section. First section span just wait. Yeah, we use 4 window. Sorry. Okay. Okay. So first wing section. Here we have first wing section. The green indicates we are in that section, first wing section. Okay. and span of this section is 0.605 feet. Okay, and the root chord from here to here, the length is 10.5 feet, and tip chord this length from here to here, that is 7.08 feet. Enter. Okay, so first section parameter is done. So what we have given in the first section: span, root chord, and tip chord. Okay, and here sweep angle. Of course, we have to use some sweep angle. Okay, so what we'll do, we'll go with 20 degree. Now we will jump to next section, second section. First section is done. No? Now we are in the second section. This one. So second section span is 0.605. Enter, and root chord is same. No need to change this one. Only we will change the tip chord. Okay, that is 4.17. Enter. Okay, so we'll go with same sweep angle, that is 20 degree. Now we will jump to next section, third section. So second section tip chord will become the third section root chord. Okay, so no need to disturb this parameter. Only we have to change the tip chord. So which means we have to reduce our tip chord. Why we have to reduce? Because as we go like this. Okay, so first section, second section, third, fourth, and fifth. So which means we have to reduce the tip chord at each and every section. That is what we are doing here. So for third section, the tip chord is 3.72 feet. Enter. And sweep angle, same 20 degree. And now we will jump to next section. That is fourth section. Third section tip chord will become fourth section root chord. Okay, and tip chord of this fourth section is 2.51 feet. 2.51. Enter. And sweep angle same 20 degree. And now we have to jump to last section, that is fifth section. So fourth section tip chord will become fifth section's root chord, and the tip chord of the fifth section is 2.07 feet. Enter. And sweep angle, of course, it's same 20 degree. Okay, yeah. Okay, so let's change this one. Okay, so aerofoil, whatever we have the default aerofoil, let it be 10% thickness to chord ratio. So we will just go with 15%. You can come to each and every cross section. You can change the aerofoil type. Okay, so now currently let it be the default whatever we have. Okay, the only thing that you have to understand how to design your model. These all things you know, how to change your aerofoil type and the parameters, right? Okay, so now what we'll do, we will check the views. Okay. Mm, third section is done correctly. Okay. Fourth section also sweep angle same 20 degree. Okay, root chord. Fourth section. Okay. Fifth section. Okay. So the sweep angle what we have, you can, if you want, you can still reduce. Okay, and you can even change your span like this. Okay, just to get this shape like this. So we'll go with the initial thing what we have given, root chord 2.5 and tip chord 2.07 and our sweep angle 20 degree. It's not like that you can't modify, even you can modify. Okay, that's why I just shown. So span 0.63, enter. Okay, span of this fifth section is 0.63 feet. Now it's perfect. Now we will save this file. Go to file, save as. So this is our part 4. Vertical stabilizer. Accept. Okay. So we have done with the main fuselage, main wing, horizontal stabilizer, vertical stabilizer, and now we will go for this one, hub. Okay, it will take just maximum 3 minutes. Okay, what we'll do, we'll go to file and new. We'll select stack component. Okay, by using stack component, we can achieve this part, or else we can create or we can design our next part 5, that is hub. Or else you can say nose portion. Okay, that is what we have here, this one. Okay, okay, so here you can observe the clearly shape is like this, right? Cross section if you take, then it will be like this. So which means from here to here, the length is 1.25 feet. That's your overall length. Okay. We'll come to Open VSP. So to design that hub, we have selected stack geometry, and after selecting the stack geometry, we have clicked on add. As soon as we add, we'll get our stack geometry on our Open VSP window. It is already displayed here. Okay, so with respect to this stack geometry, we have the geometry parameter window, stack geometry parameter window, where we have design length. Okay, so we'll come to section. So here in this section, just wait, let me delete this one. We'll add once again. Okay. So we can use stack also, but here overall length we have to mention, no? How much we have overall length? Just not mentioned here. 1.25 feet. Right? 1.25 feet. Okay. What we'll do? We'll just delete this one. Let's try fuselage. Okay. So here we can give overall length 1.25 feet. 1.25, enter. Okay. So overall length is given 1.25 feet. Now cross sections. Only one cross section is enough. Why only one cross section? Because this is our 0th cross section and this one is our first cross section. So that's why rest other cross section we'll delete that one. Okay. Second one, just cut. Okay. So here we have 0th cross section, first cross section. Okay. Yeah. So we have only one cross section. Now what we'll do? We'll close this one. Okay. Already it's closed. First cross section. Let's analyze once again this one. So like this we want shape, right? Okay. So here, first cross section, the parameter what we have, the type of cross section is ellipse type of cross section. Let's select the circle type of cross section, and the overall dia is 1 feet. 1 feet. Okay, enter. Done. Mm, mm, Okay, here we'll use one more cross section between first and yeah, between 0 and 1 we'll use one more cross section here just to give that shape. Okay, this triangle kind of shape. So we'll insert one more cross section. Yes, I will come to first cross section. Okay, so first cross section you'll use circle, same dia, 1 feet, and second cross section. Of course, we have to close our geometry. Okay, pointed type of cross section. Okay, now we can easily fix this one. Here, okay. So all of you do that. What we have done, we have given overall length 1.25 feet. Okay, so after that, we have came to section. We have 0th section. You have to close the geometry. So that's why the type of cross section which you have chosen, that is pointed type of cross section. And our first cross section, circle type of cross section. We have given value diameter 1 feet, and second cross section. Of course, again we have to change. We have to close the geometry. So that's why the type of cross section which we have chosen, that is pointed type of cross section. So now we will go to file and we'll save this one. Top view. Okay, it's like a triangle only, right? Okay, we'll save this one. Go to file and save. Part 5 hub and accept. Okay, so we have done with all the major parts of our Cessna plane. Okay, no need to design propeller. Okay, we'll just keep that on a side. So whatever we have all these 5 parts, that is our main fuselage, main wing, okay, horizontal stabilizer, vertical stabilizer, and this one hub. We'll assemble all these components. So to assemble that, what you have to do, you have to go to file and you have to call all those components. Oh, it's already 7 o'clock. Okay. So assembly we'll do tomorrow. It will take just 5 minutes time. So whatever we have covered, all these parts. Any questions from your side, students? Any questions? Any doubts? There is one message. Let me check. Okay, that time.
Sir, why we have closed the geometry in hub, sir?
Okay. So why we have to close the geometry here? You can observe. Let me share my screen once again. See here, of course, we have to close our geometry. So to close the geometry, we have to select the pointed type. Okay. here we have first section, and inside this we have one more section, no? So that is what we have to fix that section. So which means overall geometry should be closed, or else you can show your geometry second section geometry like this also with some diameter. Okay, and this diameter should be small as compared to first cross section, but you should ensure with your zeroth cross section the pointed type what we have. So according to geometry, it's completely pointed type itself. Okay, which means we have to close the geometry because here the geometry is closed. So that's why we have to select the type of cross section, or we have to choose the type of cross section, pointed type of cross section. If you don't choose the pointed type, if you choose the circle, okay, and if you give some diameter, then the geometry will be open geometry, right? So that's why choose point. So automatically geometry got closed because it's a point. That's it. Is that clear? Okay, sir, please explain propeller once again. Okay, Dikshita, tomorrow I will explain that one. Okay, after completing of our assembly part, propeller generally we can even assemble propeller also. So here we have to add the propeller. This one is already done. No? Already we have saved this one. Okay, it's saved. So I'll just delete this part. Okay. So what you have to understand, Dikshita, here we have the default propeller. You can use design tab. Under design tab, you can change the diameter of your propeller and number of blades. Okay, suppose you increase your number of blades 3 to 5, 6, 7 and all. You can type or you can vary like this. See, we got 38 number of blades. And if you want to change each and every blade, you can click on the blade and you can use this graph, or else you can use control points. So like this you can change your propeller parameters. I mean like overall propeller geometry can be changed by using all these parameters, propeller parameters. Dikshita, any other questions apart from this? You have asked about the geometrical or technical. Any questions? Just type specifically if you have any such technical questions. If you want to ask with respect to the propeller, if you clear, then just type okay, clear.
Sir, how to vary the length of that?
Dikshita, yes, yesterday also you asked me length of what? Length of what? Blade.
Length of the blades, sir.
See, length of the blade you want to increase in the sense, of course, you have to increase the dia. Then only overall your blade will change. Okay, you want to increase each and every blade length.
No, sir. Overall length means
Overall,
every blade has.
yes, that is what. Okay, so here we don't have the length parameter. Instead of length, what we have the diameter. You have to increase the diameter and you can decrease your diameter, which is nothing but you are increasing your size of your propeller, and you can also decrease your size of your propeller. Okay, here we don't have the length parameter. Instead of that, we have diameter. Okay.
Okay, sir. Thank you, sir.
Yeah. You're welcome. And any other questions? Okay. No questions. So I'll suggest all of you complete all those parts. Cessna plane. Okay, it's very simple and very easy. Okay, just complete all those parts and save in one folder. Tomorrow we have to use all those parts and we have to assemble all those parts. Okay, so that's why I'm just stopping here so that if any one of you have not done some parts, you can do and you can complete and ensure that you will be completing all those parts by tomorrow. I'm like before starting the session so that you can call each and every part on your open VSP window and you can assemble simultaneously with me. Okay. Yeah. Okay, Bhuneshwar sir. I think there is no any questions from student side. We'll stop the session. We'll continue tomorrow. Okay. Thank you. Thank you all of you.